and welcome to CX Files. I'm your host, Mark Hillary. In the next couple of episodes, I'll be speaking to some of the speakers who will feature at the forthcoming CX Tech conference in London. CX Tech takes place on October 12th and will feature several speakers focused on the future of CX and the technology that's making this happen, including me as well. Go to cxtech.events for more information on the conference. In this episode of the podcast, I'm speaking to CX Tech speaker Daniel Hulme. Daniel is the CEO of Satalia, a London-based company that provides artificial intelligence solutions to solve industry's hardest problems. He's also the director of UCL's Business Analytics MSc, applying artificial intelligence to solve business, governmental, and social problems. He's a serial speaker for Google and TEDx and is a faculty member of Singularity University. Daniel and I spoke about AI, big data, and implications of these technologies for modern CX. Okay, let's go straight to the interview. Okay, so companies now realize they need to know a lot more about their customers, and that means data, and they generally have a lot of data. But what are the common mistakes that a lot of them are making? Is it poor collection of information and data, or is it the analysis that prevents them doing more with the data they've already got?
I think there are two dimensions to this. The first dimension is the collection of data, and the second dimension is doing something useful with that data. And we see companies probably overemphasizing one dimension than the other. So, for example, there are lots of companies at the moment that are trying to hoover up as much data as possible, not quite knowing what they're going to do with it, but creating data lakes, and hopefully one day that data will be useful. But then they're also starting to realize that the infrastructure that they're pouring that data into isn't quite set up to service the needs of their applications that they need to build on top of it. So the first common mistake is just going into storing as much data as possible and not really thinking about why. The second is building applications, vertical applications, and not thinking about the kind of holistic data layer. I think that we're seeing more success in companies focusing on applications because obviously they have to build business cases around them and provide some sort of return of investment to build those applications. But again, we're seeing companies not thinking about architecting that data layer correctly, but just building applications and then creating kind of continuing to create like spaghetti systems. I think one thing that's important to call out is that there's this myth that you need to collect as much data as possible, or organizations that have the most data are going to be the most successful. And I would disagree with this. Whilst I do believe that data is the new oil, I think that it's really important for organizations to understand what data do they need to answer the question. I know that sounds obvious, but to give you an example, we were approached by a low-cost airline company a few years ago who wanted to predict churn on their website, and they said, look, we're collecting all of this data about where people are clicking and their demographics, and we know the name of their dog and what they're going to have for dinner and all this kind of stuff. And what they wanted to do is predict whether somebody was going to churn on their website. And I asked them, well, why do you churn? Why do you go and buy from a different airline? And they said price. And I said, well, are you collecting your competitor pricing? And they said no. And so if you're not collecting the right data, you're not going to be able to find the signals to help answer your question. Another example that I like, and this isn't one of ours, this is from somewhere else, but one of these low-cost, short-term loan companies was trying to predict whether people were going to default on their loan. And they said that they could collect all of this data about LinkedIn and Facebook data and all of this stuff to make these predictions. But apparently there were two very good predictors of whether somebody was going to default on their loan. The first predictor was a font that is kept in their internet cache, and that font is often found in gambling websites. And the second predictor was the number of mistakes that they made when they were filling out the application form, which was an indication of whether they were intoxicated or not. So again, you don't need to collect all of the data in the world. You just need to collect the right data, the right amount of data to make your predictions.
Mm-hmm. Okay, yeah. And I mean, given that some organizations just have collected vast lakes of data, I know that you've said in the past that it's really AI that's going to make the difference here. But when companies start applying these kind of technologies to start looking at the data, how do they even know what kind of patterns they're looking for.
Well, that's the thing is that, and that sort of leads on to your second question, is that there are people out there that are very skilled at finding patterns from data using statistics and machine learning methods and data science methods to extract patterns from data. And I would argue that organizing information to find these patterns allows us to know things about the world. So in many of the examples that I use, I talk about selling ice creams, and we know that if we plotted temperature against number of ice cream sales, we would see an upward trend. We would see a positive correlation of more ice cream sales the hotter it gets. So that allows us to know things about the world. And there are people out there that are really, really good at finding those patterns, extracting that knowledge from data. But I would argue that they need to be able to work with domain experts to help understand what those patterns actually mean. Because I could build a model, or I could put that model of I sell more ice creams when it's hot outside. I could put that knowledge into a factory, and there could be scenarios where I have an outlier situation where it's incredibly hot outside, yet my model will say I'm going to sell lots and lots and lots of ice creams because that's what my prediction says. But actually, I'm not going to sell any ice creams at all because it's too hot for people to even go outside and get an ice cream. And that's where the domain knowledge and people that understand how to interpret those patterns is vital. Does that make sense?
Yeah, absolutely. And I think that's leading on from this idea that, I mean, one of the most practical and useful applications in the corporate world is trying to determine customer intent. So, like you mentioned about the can you predict the kind of customer that's going to default on a loan? But that also means they need to look at the data, and they need to be able to tell the difference between knowing something and understanding it.
Yes. Yeah, and I guess one of the things that maybe just to call out is that humans are pretty good at looking at patterns and finding insights in three dimensions, in this three-dimensional world. Computers and machine learning are good at finding patterns in a hyper-dimensional world. So, and this is where really machine learning is quite exciting, is that now we can find correlations that it would just be impossible for humans to be able to find. The big challenge with that is that those computers will be able to find those correlations, find those patterns, and make those predictions, but it's incredibly difficult for them to explain to the human how it's making those decisions. And there's this really interesting subject that's going to be emerging out of academia over the coming years around what are called explainable algorithms or explainable AI, which is if you have this black box of a machine learning model that's making decisions based on data that you're giving it, then you need to be able to explain how and why it's making decisions, particularly for scenarios where those decisions are affecting people's lives. Mm-hmm. And so once we do crack that, and I do expect us to crack that over the coming decade or so, then it's going to be an interesting transition from humans being able to explain patterns to then machines being able to explain patterns and create narratives around what they're finding.
And is that linked then to, I mean, one of the job roles that I've heard you speaking about as developing over the next few years is going to be the decision scientist. And so how is that different from what we already talk of as data science and data scientists?
Yeah. Okay, so there's a big difference. And I think that at the moment there's lots. So there are two definitions of AI. One is a weak definition, one is a stronger definition. The weak definition is getting computers to do things that humans can do, or to do things better than humans. And I would argue that a kettle can do things better than humans. So what we've seen over the past decade is computer technologies being able to start to mimic and outperform humans at pattern recognition. Things that traditionally humans are good at, so recognizing that that's a male and that's a female and that's a dog, and being able to understand and correspond in natural language. Traditionally, that was the realm of humans, and unfortunately, we think that humans are intelligent. So when we get machines to mimic humans, we call that artificial intelligence, but it really isn't. I would argue that humans are extremely good at finding patterns, but we are terrible at making decisions. So finding patterns is the realm of statistics, data science, machine learning. That's what those technologies are good at. But once you extract those patterns, once you understand that that's a male and he's happy, then you need to be able to do something useful with that information. And doing something useful is the realm of decision science, traditionally called operations research, but it's essentially solving optimization problems. And it's a whole different set of skills. So instead of people who have statistics skills, it's people that have discrete mathematics skills, people that can solve optimization problems. And that is the area where computers are vastly superior to humans. Humans are terrible at making certain decisions. And we already know right now that machines have the capability to do that way, way better than humans ever could.
Thanks for listening to the CX Files podcast. Please tell your friends and contacts about the podcast by sharing it using the hashtag #CXFiles. And if you can leave a comment and rating on iTunes, that would be fantastic. Thank you in advance. I'm always open to ideas and suggestions, so if you want topics explored or covered on the podcast, you can find me using @MarkHillary on Twitter. That's Hillary with 2 L's. Or just search LinkedIn for Mark Hillary and CX Files. Thank you and see you next time.